3.4, Graphing Linear Equations in Standard Form. Standard form. We've talked about a linear equation. We know that it creates a line when you graph it. So the first thing we're going to look at is what standard form looks like. Standard form of a linear equation is ax plus by equals c. Now in this, x and y is still your ordered pair, and those are still your variables. Then you have a, b, and c, which are going to be your constants or your numbers. Now, when you're doing this, only one a or b can be 0 at a time. If they're both 0, then you actually don't have an equation at all. So yes, they're going to be numbers, but only one of these can be 0. Now, we're going to go over this more, but the reason I like standard form is because it's really easy to graph if you're trying to find the x and y intercepts. So kind of keep that in the back of your mind. Now, in standard form, let's say we have a horizontal line. A horizontal line is going to look something like this. This is a function. It passes the vertical line test. This is y equals b, and this occurs when a equals 0. So if you go back up here and you were to put a 0 and have 0 times x, your x term would disappear and you would just have by equals c. So essentially there you could divide off your b and you just have y equals a value. When that happens, your y-intercept is at 0, b, and the equation of your horizontal line is y equals b. Now a vertical line, okay, so vertical line, take a look at it. Keep in mind, first of all, this is not a function. And when we start talking a little bit more about slope, the slope of this guy is undefined. It's not a function. So this is x equals a, and this is when b equals 0. Example 1. Graph each linear equation. And notice it says equation here, not necessarily function. So y equals negative 2.5. Now the way I always remember this, because I could never remember whether it was horizontal or vertical, I knew it was one of them because it only had one variable, as I go, okay, y is negative 2.5, meaning x equals anything. It didn't tell me what x was, so x could be anything. So if I go out, x is 2, y is negative 2.5. Oh, what if x is 4? Y is negative 2.5. Oh, what if x is negative 3? Y is negative 2.5. So as you kind of like assign anything to x because it doesn't tell you, but you still have to drop down to negative 2.5, which is right here on the y-axis, it kind of shows you, oh, that's creating the horizontal line at y equals negative 2.5, and that is in fact a function. Example B, x is 4. So x equals 4, that's telling me, okay, then y can be anything. They're not telling me what y is. It can be anything as long as x is 4. So go over to 4. X has to be 4. Y could be 1. X is 4. Y could be 0. X is 4. Y could be 5. X is 4. Y could be negative 3. And right there, that's telling me, oh, okay, that's the one that's making the vertical line. And that one there is not a function. That is just a linear equation. It's not a function.